This is my push and pull play activity titled Survival of the Fittest for my graduate course on how young children learn science. Today I will demonstrate how students can learn about the scientific process by navigating a make-believe world. Some of the things I will focus on are the pulley system and the effects gravity and friction has on the system. Also, I will focus on how a fast or slow or a soft or hard push causes an object to move, depending on how heavy or light the ball is. This lesson is modifiable depending on the age of the students and available materials. The ideal age for this activity are 4 to 6-year-olds in pre-K or kindergarten. As an introduction to this activity, I would suggest reading the book titled Move It, Motion, Forces, and You by Adrian Mason, which is a good 30-page read aloud. Afterwards, students should be encouraged to engage in a discussion on their prior experiences. Also, key terms and vocabulary words should be explained and posted around the class as reminders. Some of the questions that should be asked to build on scientific thinking are: how can we transport items from the ground to the top of a building? What would affect this process? Is it easier or harder to push and pull things that are heavy? How far do you think this ball will go? Some of the learning standards addressed in this lesson are from the kindergarten standards: planning and conducting an investigation to compare the effects of different strengths or different directions of pushes and pulls on the motion of an object. Analyze data to determine if a design solution works as intended to change the speed or direction of an object with a push or a pull. The materials needed for this activity are building blocks, balls, a pulley system, kidney beans, which will be used to test the pulley system, and a make-believe story or model environment. Here I created a safe haven divided by a wall from the dangerous land of the dinosaurs. To begin, students will use the pulley system to transport food, and here we can test and measure how many kidney beans can be carried over the barrier before it gives way. So here is the pulley system, and I already have 7 kidney beans inside, and we're just going to make believe that somebody on the other side of the Minecraft world would be pulling the food safely over the barrier. And you see it's hard to pull it up. And here we can discuss those vocabulary words: friction, gravity, heavy versus light, and pulling. Afterwards, we will switch gears to our push activity with the use of ping pong balls and test how far each ball goes with a soft or hard push. Herein, students can make predictions, and some of the vocabulary words that would be discussed are collide, distance, force, speed, and measure. So I have my ping pong ball here. I'm just going to move this car out of the way. And I'm going to simply tap it. And there's a block at the end of the road that stops the ball from going into the pocket. Okay, to wrap up, my play activity, push and pull play activity, is titled Survival of the Fittest. The materials that were needed were building blocks, toys, a pulley system, ball, a ping pong ball, a make-believe environment, the book Move It, Motion, Forces, and You by Adrian Mason, kidney beans to test the pulley system, and a flat surface, which was my pool table. The objective was under the pre-K domain of cognition and knowledge of the world, physical science, wherein tools and materials were used to design and build a device that causes an object to move with a push or a pull. The cross-cutting concepts were cause and effect, and the age range is 4 to 6 years old, pre-K and kindergarten. Some of the questions that are asked to build on scientific thinking are: how can you transport items from the ground to the top of a building, and how does friction and gravity affect this process? Students can also share experiences with jumping, and we could discuss how gravity pulls you back down. That's the end of my video. I look forward to your feedback.